All right, we're going to talk about theoretical and experimental probability. So we want to know some of this information. So an outcome is the result of a trial. So what happens? Sample space is all possible outcomes. An event is any outcome or a group of outcomes. So like if we're talking about like a standard die, our sample space would be 1, 2, 3, 4, 5, 6. The outcome would be what we roll on that die. Okay, the event might be what's the probability I roll a 6. Okay. So a probability, or P of an event, so they'll put what we're looking for inside of parentheses. How likely is that event to occur? So that's what probability is how likely is it to occur? So the first thing we're going to look at is theoretical. So this is what you would expect it to be. Okay, so the probability event is the number of favorable outcomes divided by the number of possible outcomes. Okay, so for example, if I said, go back to our standard cube. So if I have a standard die, 1, 2, 3, 4, 5, 6, what is the probability that I roll a 6? So my theoretical probability would be my favorable outcomes, which is 6, over the total possible, which is 6. So I have the number 6, which is 1 favorable outcome, 6 possible. So 1/6 of the time you would expect to roll a 6 on there. The complement is the opposite of it. It's the complement of the event is the outcomes in the sample space that are not an event. So I would say in our example, we said, what's the probability of rolling a 6? It was 1/6. The complement of that is what is the probability of not rolling a 6? Okay? And the way we find that is the probability of not an event is equal to 1 minus the probability of the event. Okay? So one of the things is that your probabilities always have to add up to 1. So the probability of an event plus the probability of non-event always has to add up to 1. Okay? So we'll look at theoretical probability, and then we're going to look at the complement of that probability. Okay? So let's take our standard die. Okay, so our outcomes are 1, 2, 3, 4, 5, 6. And what's the probability that I will roll a multiple of 3? So the probability of a multiple of 3. Well, so the first thing I want to know is multiples of 3. Well, how many multiples of 3 are there? Well, there's just 3 and 6. So there's 2 multiples of 3. We know that there's total, so this would be 2 over 6, which is 1/3. Now, the probability of rolling not a multiple of 3 is equal to 1 minus the probability of rolling a 3. And so this becomes 1 minus 1/3. Well, it gives me 3/3 minus 1/3, which is 2/3. So that's probability, theoretical probability. Now, built into probability is this thing called odds. Now, odds is a comparison of the favorable outcomes compared to the unfavorable outcomes. Okay? So they're slightly different than probability, but they go hand in hand. So here we have a spinner that has 1 through 8 equally represented. So we want to know the odds of spinning a number greater than or equal to 6. Well, what are the favorable outcomes? Well, that's 6, 7, 8. So there's 3 there. Unfavorable are 1, 2, 3, 4, 5. So our odds would be 3 to 5. Or you could write it as a fraction, 3/5. So odds are a comparison of your favorable to your unfavorable. Okay? So experimental probability goes back to kind of the idea of theoretical, but experimental probability is how many actual successes you got over how many times the experiment was done. So if we're rolling a die, we would roll the die, record our results, and then use those results. Okay? So if I'm flipping a coin, I flip a coin and I get a head. My first one is a head. We know theoretical probability should be 1 out of 2, 1/2, right? Okay? So our experimental probability is using our experiment. So a skateboard manufacturer pulls 1,000 skateboards randomly and checks those skateboards for defects. If they find that 992 of those had no defects. 8 of them had defects. So what's the probability of not having a defect? Well, our experimental probability, we're going to take the number of successes, 992 over 1,000. We're going to convert that to a percentage. So decimal, that's 99.992 or 99.2%. So 99.2% of their skateboards are without defect. Now, we're going to use this experimental probability on one more example. So we select 500 random households. If of those 500, and we're trying to see if they have a dog, so this is like example 5. So you ask 500 randomly selected households in your town if they have a dog. Of the 500, so this is our sample space, right? Of those, 197 say they have a dog. If your town has 24,800 people, 8 households, about how many households are likely to have a dog? So what we're going to do is we're going to take our experiment, we're going to find the probability, our experimental probability of a dog, and we're going to and then use that to find out how many households we have in 24,800. This is supposed to be an 8. Okay? So we have 197 out of 500. That's our probability of a dog. Okay? Now, in our town, we would expect this to be 197 over 500 times 24,800. And so we're going to multiply those out and kind of get an estimate here. So if I multiply this out, 197 times 24,800 divided by 500, we're going to get 9,771.2 households. So we would expect 9,771 households to have a dog. Okay. So that's using our experimental probability to kind of expand on that and kind of take it to an entire population. So that's theoretical probability, that's odds, that's experimental probability.